Hi everyone, welcome back to another lesson. Today we're going to talk about transformations. Specifically, we're going to talk about reflections. Okay, how do we reflect a shape? And a bunch of different vocab that's going to come with it. We'll discuss that throughout the lesson. My notes are posted online, so you can look at that and use that as a nice reference. Okay, let's say we have this triangle and we want to reflect it across this line. Now, couple vocab terms, I should say. First thing. Any line that you're trying to reflect across, we just call that the line of reflection. I know, isn't that a shocker? All right, line of reflection. It's whatever you're trying to move an object over to that line. What we start with, this guy right here, we call that the pre-image. Okay. And that's just, like I said, it's what we start with. What we come up with over here, we're going to call the image. All right? Now, think of a mirror for a second. If you look in the mirror, or if I look at myself right now with this video, your image is showing you the same distance from that mirror, right? You guys are equally distant, just like me right now. It's like 3D. I'm coming right for you. My distance to the laptop is showing the same distance through the video, okay? So reflections are equally distant to that line of reflection. And what's most important is the distance has to be perpendicular to that line, okay? So what you're going to do, if you take something like this, you're going to start where A is, and you're going to measure out how far A is to this line of reflection. Okay, so for me, this is roughly 7 inches. So I'm going to go ahead and move 7 inches over here, put a point, okay, and I'm going to call this A prime. Okay, that little looks like an apostrophe there, but that's indicating to you that this coordinate has just been reflected. It's indicating that a change happened, okay? Once again, the distance would be perpendicular to that line. Now do the same thing. So if I look at my B coordinate, I'm going to measure it from the line, and it's about 3 inches. So I'm going to go ahead, mark out 3 inches. I'll put a point, and that would be B prime. And then for the last one, I'll measure C to the line of reflection, and I can see it's about 7 inches. So I'm going to match 7 inches over here. C prime, and then draw my triangle. Now, this is obviously, I don't really have much of a grid. I'm trying to do this with just a yardstick here and some markers, but you could be a lot more accurate on some grid paper, okay? But there it is. There's my triangle that it's being reflected. So this is called the image, okay? And this is what we have as the pre-image, and that's it. Okay? Anytime you're going to reflect an object, it's always equally distant to this guy. Questions? Concerns? Dilemmas? No? You guys are always so quiet. Let's do an example together. Okay? We want to reflect this triangle across the x-axis. Now, there we go. Okay, so here is my lovely xy plane. Ooh, there's a small glare for you. Can I don't know if I can change that. I'm going to do the best I can so that way you can still see it, though. So I do apologize for that little bit of a glare. Let's go ahead and graph the points first. Okay, so helps if the marker is uncapped. So 1, 2, 3, 4, 5, 1, 2, 3. So here's point A, B is at 2, 0, and then C is at 1, 2, right here. And I should be accurate with this. Let me draw some nice straight lines. There we go. Just like that. Okay, so there's my pre-image. I'm going to reflect this across the x-axis. That means that right here, okay, is my line of reflection. So I'll put that notations over here, or just as a note. Line of reflection. In other words, I'm going to take this triangle and reflect it over that line. And remember, it has to be equally distant. Look at point B for a second. Point B is on that mirror, okay? Therefore, it's not going anywhere. It's not going to change. B prime is going to be right next to it. Now look at C for a second. C is 2 spaces away from the line. And we can see just by the grid. I'm going to go 2 more spaces beneath it, has to match, and I'll put C prime right there. And then finally, look at A. A is 3 spaces away to the line of reflection. Therefore, I'm going to mimic it and move 3 spaces down here. I'm going to put A prime next to it. So far, so good. Now, we graph. Well, not graph. Now we draw lines, I should say. Go. And there we go. I love doing these types of graphs. I think the result is very cool looking, okay? But there it is. Once again, this is my image. This is my pre-image. We can tell it's the image by the prime marks. Let's take a step back. Can we come up with a rule just by looking at the coordinates if I want to reflect it? Without graphing, can we come up with a rule? I think we can. Look at the coordinates for the C prime. And in fact, I'm going to go ahead and write down what the coordinates are next to it, just so we have it. Okay. A prime's coordinates, okay, would be -5, -3. B prime's coordinates are the same, and C prime coordinates are 1, -2. If I make a comparison here, and here's what I'm going to do real quick. I'm going to show off the grid for a second. If we compare these guys, I notice that the x-coordinate never changes. And if we look at the graph, we can see that the x-coordinate never changes. Only the y-coordinate does, and specifically, it changes by the sign of it, right? Look at this. We start at 3, we go to -3. 0 is 0, there's no opposite of that. 2 to -2. What I would like for you to do in your notes is write down this rule. I will take each coordinate, if I'm reflecting across the x-axis, I'll keep the x-coordinate the same, I'll take the opposite of the y-coordinate. Now notice, I didn't say the negative of it. Even though there's a negative sign there, I'm implying we want the opposite side of it. Okay? And there we go. That's reflections across the x-axis. Any questions on the rule or how to do that? You're literally just counting spaces to that line of reflection. Okay? All right. Now, we're going to change this up a bit. You might guess what's next. We're not going to reflect across the x-axis anymore. We're going to reflect across the y-axis. I'm sure at home you're saying that with me, right? You're following along. Hope you are. Okay. Let me write down these coordinates. Oh, this is going to be a really cool picture. You're going to like this. I hope you're going to like this. Okay. All right. Here's my next example. I'm going to take these coordinates and I'm going to graph it across the y-axis. Let's graph the pre-image first. So -4 and 1, so there's point P. 2 and 3, there's Q. R is 2, -1. And S is -4, -3. And let me just... Usually I say pause the video and try to solve this yourself, but it's taken me some time to graph this. Therefore, you don't have to really pause the video. You have time. All right, there's my pre-image. Now I want to reflect this across the y-axis. You're probably noticing right now the y-axis is going through the shape. That's okay. Wherever your points are, they have to go across that line to be truly reflected. In other words, Q and R, these points have to go in this direction. P and S would have to go in this direction in order for it to be reflected. Okay? Let's try it out. P is 1, 2, 3, 4 spaces away. So what I'm going to do is mimic it on the other side. I'm going to go 4 spaces away and put right here P prime. S, same thing. It's 4 S's away, or 4 S's. It's 4 spaces away. So on the other side, I'm going to mimic that and put it 4 spaces away. So there's S prime. Remember, the prime marks indicate that it's been reflected. Okay, it's a symbol that we're using. Q is 2 spaces away. So I'm going to go 2 spaces away over here. Here would be Q prime. And R, which is here, is 2 spaces away. So then I'm going to go 2 spaces away over here. So here's R prime. At first, this looks a little bit messy because all the points are kind of mixed together. That's why the prime marks are so important. Let's go ahead, connect our dots. You are going to like this. There's my result. Isn't that cool? I love seeing. Think of it this way: you can come up with a lot of different designs yourself. But here it is. My image and pre-image are intersecting, but that's okay, as long as the points got reflected across right here. This was my line of reflection. Okay, that's the important thing. Now you're probably guessing what I'm going to say next, and that is, what's the rule? If I was looking at the coordinates, what's changing, and can I make a generalization of it? Let's write down the coordinates next to this. Okay, P prime is at 4. 4 and 1. Q prime is at -2, 3. R prime is at -2, -1. S prime is at 4, -3. Looking at the coordinates, I can see that the y coordinate stayed the same for each reflection. But the x coordinate, we can notice that the signs changed for each one of them. Therefore, the rule is, when you're reflecting across the y-axis, you take your point, all right, and you keep the y-coordinate the same, but you take the opposite sign for the x-coordinate. There's my rule. And I'd like for you to write that down in your notes as well. And this is just reflecting across the y-axis. All right? Questions, concerns? Hopefully you thought that this was cool. I like this. We always talked about, remember at the beginning of the year we talked about intersecting planes, and that picture can be hard to draw? We were able to draw that pretty easily using some reflection stuff. Okay, enough geeking out, I guess. We got one more example to go. Okay, shut that off real quick. The last one we're going to talk about is reflecting across the line y equals x. Okay? All right. Let's do this example. This is going to be a quadrilateral. J, 4, 1, there's K, 3, negative 3 is L, 0, negative 4 is M. I'll move out of your way, don't worry. I can't see, Mr. McCullough. You're blocking it. I know. Reflecting across the line y equals x. First off, y equals x. Let's talk about that part. If you remember, y equals x is the diagonal, okay, that goes through the origin with a slope of 1. Go back to your Algebra 1 days. Okay? I'm going to try my best to graph that. It's probably not going to be as accurate. It's going to look like this. Okay? This is the y equals x, and can't talk right now. And that's our line of reflection. Okay? And like I said, I think, let me try that one more time. It's going to be close. Let me try this. 1, 2, 2. Ah. There we go. That, I think, looks a little bit better. Yeah, I think that looks better. Line of reflection. Remember, a reflection is equally distant. Every point is equally distant to that line, and you're going to match it on the other side. And that distance has to be perpendicular for it to work. Okay. Well, here's what you're going to do. Notice that J is right on that line of reflection. Is J going anywhere? No. J prime is going to be right there. J prime's not moving. All right? It's on the mirror. If I measure M to this line, and I mimic it on the other side, okay, I'm going to get M to be right here. There's M prime, okay? If I were to measure L, okay, if I measure L from here to the line and mimic it over here, okay, I'm going to get L prime to be roughly there. And I know it looks a little bit off, sorry. Let me just tilt it, there we go. So if I were to measure L to L prime, if I mimic the distance from here to here, L prime is going to be located at this point. I'm going to write down the coordinates, don't worry, okay? And then K, if I mimic it as well, I'm going to get K to be up here. Now, let me go ahead and draw this, and we're going to explain what's happening here. Because all I've done is measured to figure this guy out. Okay, so let's see, J's there. J to K. And that goes to, there we go. Once again, I think the picture looks lovely. Kind of reminds you like maybe a butterfly, or actually scissors or something like that. I don't know. Okay, J prime didn't change. K prime went to 1, 4. L prime went to -3 and 3. And N prime went to -4, 0. And I got those just by measuring. Now, I did quickly go through it just for the time of the video. But let's say I didn't want to measure. It's easier to measure when it comes to x and y axes, right? You can just count the spaces. But if it's this line, I need a ruler to do that. Or do you? Okay? When it comes to an xy grid, you don't. Look at the behavior of these points. J didn't change, but look at K, L, and M. Notice how you took the coordinates and you literally changed their positions, right? So 4, 1 became 1, 4. 3, -3 became -3, 3, and so forth. Therefore, I could say my rule for this guy, I'm going to take the coordinates and I'm going to flip them. I'm going to change their positions. So the x-coordinate now becomes the y-coordinate. And the y-coordinate now becomes the new x-coordinate. All right? I would highly recommend that when you do this, okay, write the points down first. Now, could you measure with a ruler and get to the same conclusion? Yes, but there could be errors with that. Depends on how you measure, right? If you're good with a ruler, this one's no problem. But if you're not, you could get some different results. That's why I'm saying when you get to a problem where it says reflect across y equals x, write these coordinates down first. All it is, the rule is just to flip them, okay? Then graph it to show what the result is. Okay? There we go. Tell you what, bonus. This just kind of came in my head right now. I think this would be a good thing to include. I'm just going to do a real quick example. Now, I do have examples in my notes that go with this, okay? Feel free to look at that. What happens if I want to reflect across like x equals 2, or if I want to reflect across something like y equals like negative, well, let's say negative 3. Okay? That's not x and y axes anymore, right? That's a little bit different. If you remember from your Algebra 1 days, x equals 2, okay, that's a vertical line that's going right through the x-coordinate at 2. Just like that. Okay? So this would be x equals 2. Now, if I had a point right here, let's call this point A, and I want to reflect it across the line x equals 2, draw your line of reflection, and then count how many spaces over. So 1, 2, 3, then 1, 2, 3. There's A prime for me. Okay? It looks weird because you see these other grid lines. Okay, if I got rid of it, let me get rid of the grid lines for a second. You can see visually, this is a lot better, okay? You can see visually that these are equally spaced apart from this line. But because you're doing this on a graph, it can get a little confusing because you're looking at this line too. You have to block that out. This is now your new line of reflection. That's what you have to use. All right? Let's go and look at this guy. Y equals negative 3. Okay? If I want to reflect across that line, I'm going to go where negative 3 is on the y-axis and draw a horizontal line. Maybe not that well, because for some reason I can't draw straight lines. There we go. Okay. Here it is, y equals negative 3. Now let's say I have a point right here, we'll call that point A, and I want to reflect it across this line. I'm going to go down, let me just make that more accurate. I'm going to see how far it is, so it's going to be 1, 2, 3, and then I'm going to go down 1, 2, 3. There's A prime. Okay? Same thing, they have to be equally distant, and they have to be perpendicular to that line. Do not, under any circumstance, remember the rule for reflecting across the x and y axes? That doesn't quite fit for this, okay? So I don't want you to get the rules mixed up with something like this. That's it. That's reflections for you, okay? If you don't have a grid, okay, if you don't have XY paper, and let's just say that you just want to reflect an image, remember, we could do that. That was the very first example we did in this video. Just make sure you have some sort of line that you want to reflect it across, and using a ruler, measure how far one of your vertices, points, or a major feature of the object you're looking at is from this line, and mimic it to the other side. Okay? So I'm going to make sure you know that you don't always have to have graph paper to do reflections. You could do it on your own, just using a ruler. All right? That's it, guys. That's reflections for you. If you have any questions, please let me know. and I will see you all in the next lesson video. Take care.